Now, let's move to the third method, which is called exponential smoothing method. Okay, so you may wonder what is the difference between exponential smoothing and a weighted moving average. Actually, this exponential smoothing method and the weighted average method, each method has its own advantage. So weighted average method, okay, we put different weights on different data, right? Uh, when we forecast for July month, we probably use, let's say, the previous 3 months' data, right, in order to predict for uh, the basically the last month and the next month, which is the July month, right? Um, but sometimes in the real situation, you may not actually have many real data, all right? You may only have, let's say, you may only can use the most recent data to predict for the next period of time, okay? So since the weighted moving average method it needs you to include, okay, all of the past data in a period of time, okay, you actually have a little relative higher requirement, okay, before you can use the weighted average, moving average, all right? But instead, in the exponential smoothing, okay, we can directly just use one previous data to predict for the next period, okay? So you see that if we can use exponential smoothing method, okay, by just using one past data, and if we can still provide you a relative accurate result, it's actually very good, right? Because uh, a lot of different reasons. Actually, I already list here. All right. First of all, it can be very accurate. Okay, it can be very accurate, but just using one previous data, okay, to predict for the next data, and of course, it's easier, right? It's easier because you just use one data to predict the next period of time. It will need less calculation. All right, and of course, the computer storage requirements are small, and you can actually very easy for you to test whether it's accurate or not, right? Now, we already talked about the characteristic, but how to formulate is showing in this slide. The forecast of this period equals to the forecast of the last period plus, okay, plus alpha. Okay, we call it adjustment index. Okay, we just talk about this is alpha basically, right? Alpha is the adjustment index times the actual market demand in last period minus the forecast of the market demand in last period. That's it. So you see that you only need the data, okay, from last period, no matter it's um, forecast in the last period or the actual market demand in the last period. Okay, as long as you know this data, also you need to know alpha. After you know all these things, okay, if you know the information related to related to the previous period, by using this simple equation, you can get the forecast for a current period. Okay, that's a key point of the exponential smoothing. Very, very simple. Now, um, yeah, this is actually a class extra. This is actually an example from the textbook. Okay, uh, let's still use this class example. Okay, the key idea is exactly the same, but this question, uh, the example I use here is a little bit simpler. All right. Now, suppose, okay, we're trying to use a single exponential smoothing method with alpha equals 3, okay, and a June forecast equals 11. Okay, suppose I tell you these two information. I want you to figure out what is the July forecast. Okay, what is the July forecast? How to calculate it? Okay, the process is very simple. First of all, in order to forecast for July, okay, what do you need? You need a forecast for, if this is a forecast for July, then what is this? This is a forecast for June, right? Because it's T minus 1. Alpha is the adjustment ratio. Basically, it's adjustment coefficient, okay? In most cases, we will let you know what is alpha. What is this? This is actual market demand, okay? The actual market demand in which period? In June, right? Because it's the last period in June. All right. Now, what is the? Let's actually look at this formulation. All right. What is the forecast in July? Sorry. we're trying to guess the forecast in July. What is the forecast in June? The forecast in June should be, I tell you, forecast in June should be 11. Okay, so if we follow this basic equation shown here, all right, the first element would be 11. All right, now the next one would be alpha. Do I tell you? Yes, alpha equals 0.3. That's it. Okay, now next, what is AT minus 1? The actual market demand in June. What is the actual market demand in June? Remember, in this table, all these are history data, right? These are reflecting the actual market demand. That's why the actual market demand in June is 19. All right, 19. So this is 19. And also, FT minus 1 basically is still 11 because June forecast is 11. So if you plug in the corresponding element within this equation, okay, showing here, you will see the basic equation will be shown here, all right? And the result will be 13.4. What it means by 13.4? 13.4 means that your July forecast would be 13.4. That's it. You see, just one line equation, you get the result. But the key point is not the calculation itself. It's to understand the basic logic and the reasoning why we do like this. Okay, so give you some better sense about why the equations look like this. Right? You see, this is a forecast for current period, right? This is a forecast from last period. You can view this, the forecast from last period, as the starting point. But you know that we cannot directly use the last period's forecast to predict for this forecast, right? We have to do some adjustment. Right? So here, this part is basically reflecting adjustment. How do we simply do the adjustment? We use adjustment coefficient times what's this basically. Think about it, what's this? This is actually the difference between the actual market demand and the forecast of the market demand in last period. So basically, by just looking at the actual market demand and forecast in last period, look at the difference, we times the corresponding adjustment coefficient, and then we add up this whole thing to the forecast of the last period. Okay, basically we're doing some adjustment based on this forecast in last period in order to get the forecast for this current period. That's it. Very simple. All right. Now, okay. The next quantitative method is also related to exponential smoothing, but instead of directly using exponential smoothing, we actually further incorporate the trend effect. Okay, so actually in the exponential smoothing without trend effect, we directly just calculate as what we just did, right? But here, the exponential smoothing, after we incorporate the trend effect, okay, the calculation itself is still simple, okay, as long as you understand the key point here. All right. So the key point here, basically, the calculation itself probably would be a little bit harder than the exponential smoothing method itself. Okay, but the reason why here, besides exponential smoothing, we need some adjustment for a trend because actually the previous statistician already figured out that this method will be a little bit more accurate. Okay, compared to the exponential smoothing without trend effect, because actually here conceptually, after we add up the trend effect, the exponential smoothing method will be basically incorporating more factors that may impact the market demand. That's why here it's becoming more and more accurate. All right. So these three are the equations. Basically, in order to, what is our target? Our target is FIT. What is that? This is forecasting. Okay, incorporating trend. That's it. Okay, forecasting incorporating trend at a period t equals to forecasting before you incorporating trend in period t plus the trend at period t. Okay, but we cannot directly get this result. Okay, we first need to calculate FT and also the TT. You see these two elements showing this equation. So basically, we need to first look at FT value and also the TT value. Okay, before we can calculate, we sum it up, get the FIT at the period t. All right. So first of all, FIT t minus 1. basically means that first let's look at this equation, all right? So the forecast after integrating trend at period t, okay, minus 1 at period t minus 1, plus the adjustment, okay, coefficient times the actual market demand in period t minus 1 minus the forecast after incorporating trend at t minus 1. You see, this equation looks very similar as what we just said right here. Okay, as what we just right here. The only difference is that here, as the right hand side, okay, so in period t minus 1, we use the forecast, okay, after incorporating trend for period t minus 1, okay? And then what we get is called FT. What is FT? FT means the forecast of period t without considering the trend effect in period t, okay? Actually, the definition is already showing here, all right? It's the forecast of market demand without incorporating the trend effect in period t. But we know that since we're using exponential smoothing, okay, by incorporating the trend effect, we have to do one further step. We need to basically measure the amount of the trend effect. Actually, the calculation here is also very simple. First of all, in order to get the trend in period t, we start from trend in t minus 1, basically the last period, and then plus the coefficient for trend adjustment, times this difference. What is difference? You already get ft from the previous equation, right? Ft can be get within the previous equation, okay? And you also have the forecast of after incorporating trend in period t minus 1. If you calculate the difference times the sigma and then plus the t, the trend in last period, you will get the trend in current period. After you get these two, the forecast before incorporating trend in period t and the trend itself in period t, you add them up, you get the forecast after incorporating trend in period t. That's it. Okay, very simple. Now, actually here I not use that classic example, but I use a new example to illustrate. All right. So the context itself is very, very simple. All right. So basically, if I just tell you that the previous forecast, okay, including a trend, is 110. All right. And if I tell you that the previous estimate of the trend, okay, in last period basically is 10 itself. All right. And if I also tell you that alpha equals 0.2, sigma equals 0.3, the actual market demand in period t minus 1 was 115, all right? How to get the forecast after incorporating trend for this month, okay? Or for more specific for period t, basically, all right? So you basically just follow the equations that I just said, okay? Which equation you should start from? You should start from this equation. Basically the second one, okay? The second one. You see, that's what I list here. So the forecasting after integrating trend in period t minus 1, I already tell you, it's 110, right? And you need to do some adjustment based on that. The adjustment itself basically is measured by this part. Alpha is 0.2, that's what I give to you. What is the actual market demand? See, the actual market demand for period t minus 1 was 115. That's why here this is 115. Minus the forecast after integrating the trend in period t minus 1, which is 110 again, right? So basically, you just plug into all these numbers correctly, and then you get a result, which is 111. So 111 itself represents FT. What means FT? Is a forecast before you incorporate the trend effect in period t. That's it. So, but our target basically is a forecast of the forecast after incorporating trend at period t, right? That's our target. That's why here, before we can get this, we have to first calculate the trend in period t. Very simple. In order to get a trend in period t, we first basically calculate trend in period t minus 1, and then plus this delta, all right? What is the trend in period t minus 1? It's 10, I already tell you, all right? What is sigma? It's 0.3, right? What is the difference between ft and fit t minus 1? ft is already calculated from the last equation, which is 111. And FIT minus 1 is already given from the context, which is 110. So you just calculate the difference, times 0.3 and then plus 10. All right, that will give you the trend impurity, which is 10.3. After you get both FT and TT, you add these two up to get the final result, which is the 121.3. So 121.3 basically represents a forecast after you incorporate trend effect in period T. All right, that's it. Now, yeah. So for choosing the alpha and theta, these two parameters. So basically, in the questions, normally we will give to you directly. But in the real cases, you may wonder why we choose alpha or theta in specific value as specific value. So first of all, alpha represents the adjustment related to the forecast, and delta represents adjustment related to the trend. All right, we already talked about that. But in the real cases, when we deal with let's say when we deal with some business application by using the exponential smoothing with the trend methods, normally we have to kind of judge what is the alpha value and the sigma value. Okay, the best way to do it is based on some management judgment. All right, we won't actually talk about this in this course, but just let you know that actually sometimes the management judgment itself is very, very important. It's crucial. All right, so yeah, here just give you some sense about where the alpha and sigma comes from. That's it. All right. Okay. The next method that we will use is called linear regression analysis. All right. So if you took BSTAT, right? I think most of you will took BSTAT, and if you took BSTAT, you probably learned linear regression analysis already. Linear regression analysis, basically, let me give some sense about linear regression analysis. You may already forget about the key point of here, all right? So first of all, why we need linear regression? Linear regression analysis itself is basically trying to build up a correlation, all right, between or among different variables, okay? We're trying to figure out the relationship between or among a few different variables, okay? A few different variables. That's the reason of doing linear regression, okay? Or more descriptively, we want to know whether when one variable is increasing, whether another variable will increase or decrease by how much amount, okay? That's the key point of linear regression analysis, okay? Now, then if I give you some data, how you can implement linear regression, okay? Probably I think in your BSTAT course, you probably learn both the simple linear regression and multiple linear regression with the support from Excel. All right, from Excel. Here, Excel ways, of course, is also very important way of doing it. But here, we do require you guys to manually calculate, okay, the linear regression equation, okay, especially in the simple linear regression equation, okay, yourself, all right, because actually by calculating this whole procedure, it will give you a better sense about, how you can generate the, you see, basically the intercept and also the coefficient when we try to do the time series analysis within the specific operations management field, all right. So basically, in the multiple linear regression, it's very, very hard to calculate the, those coefficients yourself. But in the simple linear regression, actually, although the calculations process itself is a little bit long, but as long as you understand the key point here, it's not that difficult. All right, let me leave you guys to go through this. Okay. Yeah. First of all, you see this. No matter we use Excel or we manually calculate, we follow least squared methods. All right, we follow least squared methods. So you can see that actually on this plot, right? Basically, let's say we're exploring how. Let's say we have two variables. All right, we are trying to explore how the variable x will impact another variable, which is called y. All right, so basically we're trying to build up a relationship between x and y. All right. And in the plot, you can see that, all right, basically these different dots showing here, okay, are viewed as different real data, okay. But what you can build up by using the regression analysis, okay, would be a straight line. So the straight line basically is just the estimation. It's just the estimation of the main information that are captured within every different dots. Okay, but you see that since the not all of the data, not all of these dots are exactly standing at this straight line, right? But it's all around this straight line. It means that actually the straight line capture, okay, most of the information from this all these different dots, but it doesn't fully capture, because if it fully captured, every dot should be within this line, right? But you see, since this all these lines, they are not actually looks like a straight line, right? You cannot actually plot a straight line that can cover all of the data points showing within this plot. That's why here, as long as this straight line is close to every dot, that's already good enough. Okay, and the underlying method that we use is called the least square method. Okay, so the least square method itself is just the name of the method that we use. Okay, but the most important thing is to figure out basically how we implement after we have those data, right? You see that in this example, if we have the sales data for the past 12 quarters, all right, how we can build up the function, okay, y equals to a plus b times x, right? You may already learn function before, right? So we try to basically get the function, okay, which I show here, okay? The function that we want to, that we are trying, let me write down here. The function that we are trying to build up is y equals to a plus b times, let's say, t, okay? If we view y as the as the dependent variable, okay, or we call it the response variable. If we view t as the independent variable, more specifically, t can represent the time, okay? Y represents the forecast of the market demand, all right? Since we're trying to apply into our specific problems, right? So y can be viewed as the market demand forecast. T represents corresponding time, okay? So what we are trying to estimate basically is the a value and the b value within this function, right? As long as we know a and b, no matter which t value we put into this equation, we will get the corresponding y value, right? We'll get the corresponding y value. That's very simple, all right? So here, the two equations showing in front here exactly tell you how to get a and b within this equation. Actually, the equation itself is very simple, okay? It's very simple. Let me lead you guys to have some to understand the both equations here, all right? So it's actually following this example. This example, to be honest, is already a little bit comprehensive because there are a lot of data shown here, all right? So if I ask you guys to calculate, let's say, a and b within simple linear regression, all right? I won't actually include too many data points because this course is not about a calculation. All right, this course is about how you can properly apply those mathematical quantitative methods or conceptual ideas into operations management field. Okay, so that's the key point. So probably if I wanted to do something, I may just give you 4 or 5 different data and let you to calculate. That's already good enough. All right. So here you see that since within this simple linear regression, right, we are trying to capture how this time t will impact the forecast, right? That's what we are trying to do. And within this function, the two values that we need to estimate is a and also b, okay? Or a and b. And more specifically, when we try to estimate a and b, we need to first estimate b instead of a, okay? We have to do that because this is basically the standard statistical process, okay? We need to do this. So this would be the equation that we really need. Okay, now let's look at this equation. So first of all, within this equation, let's look at every element one by one, all right? Here's one called summation ty, Okay, you see here, still the same example. They already put everything at the right hand side, right? T from 1 to 12. Y is basically 600, 1,550, right? You see, all these things are listed in two columns. All right. Now, what is the summation of Ty means? Okay, what is summation of Ty means? You see that for every row, when T equals 1, Y equals how many? 600, right? So Ty is a value, which is 600, okay? For every row, you need to calculate the corresponding Ty. The summation of Ty means after you calculate every element of Ty, you need to add all them up. All right, that's basically mathematically it's very simple from the from technical point of view. All right, basically what it means is that after you know all the t and y that's given from the context, right? You calculate every Ty, every element, and then what you need to do is to sum it up to get the summation of Ty. So what is the summation of Ty in this specific context? You see, after you get every Ty, you add all them up. The summation is shown here, which is 268,000 and then 200. All right. So this will be one value. Next, what is n? N represent what? N represent a pair of data. Okay, remember it hard. That's the pair of data. How many pairs we have? You have data related to period 1, 2, 3, 4, 5 until 12, right? You have 12 pair of data. Okay, pair of data. So n should be 12. What is t bar? T bar represents average of t. The average of t. What is average of t? You add up all of those different values and divide by the corresponding number of the values. You add up. You basically use 1 plus 2 plus 3 plus 4 plus 5 plus 12, right? Until plus 12. How many values do you have? 12. So basically you add all those different values and then divide by 12. The result would be 78. Sorry, the summation is 78. What is after you divide it by 12, what is the result? Let me check. The 78 divided by 12, all right, which would be a 6.5, which is 6.5. That's why you see the second value shown here is 6.5. Okay, this is actually after calculation. What is the y bar? Similarly, you basically add up all those elements shown here, which is 3,300. 33,350, right? That's the summation of y, and then divide by how many? Still 12, because you have 12 different values. That's why this would be the value shown here. Okay, and then the next one, the summation t squared. So this is similar as the summation of ty. The only difference is that you first need to calculate t squared for every row. Okay, for every row. So you see that t squared is showing up here. All right. So t squared. So 1 times 1 is 1, right? 2 squared is what? It's 4. 3 squared is what? It's 9. That's what you see. The number showing here. All right. But what we want is the summation of t squared. In each row, you will have a t squared value, right? But in summation, you need to add all them up. You need to add all them up from the beginning to the end. So the summation will be 650. That's why here this 650. And then minus still n. What is n? N is 12. What is t bar? We already talked about t bar, right? T bar is 6.5. But here, what we want is not t bar itself. We want a t bar and then square of it. Okay, take the square of it. So that's why here you see it's 12 times 6.5 and then square. Okay, that's why you see the whole value showing here. Okay, I already go through every element here. Okay, and then finally you get the B, which is 359.6. Okay, 359.6. Now, after you get B, you can simply get A. Okay, you almost get down. All right, after you get B, you see A equals to y bar minus B times t bar. Can you calculate y bar? Yes, I just mentioned how to calculate y bar, right? Add all them up, add all this value showing in this column, and then divide by 12 to get y bar. What is t bar? T bar is to basically add up all these values within this column and divide by 12, right? What is B? You just get it, 359.6, all right? So Lastly, you will get A, which is 441.67. Okay, 441.67. So after you get the value for A and B, within this equation showing here, the equation showing here, all right, you can plug in. Basically, y equals to what? Y equals to 441.67 plus 359.6 times t. All right, that's your result. Okay, then okay, if I want to forecast for a certain specific period, okay, for a certain period. Now you see that we have the actual data from 1 to 12. If I want to forecast for period 13, how to do it? Very, very simple. After you get A and B, if you want to forecast for period 13, you just use 13, okay? Plug 13, value 13 into this equation. Since you already know A and B, and also you plug in 13 into this equation, you will get the corresponding forecast. Very easy. How about 14? How about 15? Same thing, right? Okay. Now, another thing, basically, the regression with Excel. All right. So this is also, I really recommend every one of you to know at least know how to use the Excel to get the regression analysis. Okay, that's actually also very important. And here, as I show here, I list a very quick instructional video. All right, just 3 or 4 minutes to help you how to basically set up the regression analysis within Excel. Okay, very simple, but it's very applicable. Okay, I think as long as you understand, you can widely use that in the future business boards. All right. So if you have any question, let me know. All right. Now it's a time series decomposition. Oh, okay. So the time series decomposition, we won't cover. Oh, sorry. Get back to the regression with Excel. So we won't actually test the regression with Excel in your exams. All right, but um, maybe we may have some question related to the regression with Excel in the homework, but it won't be covered with the exam, all right? Because during the exam, we won't actually have access for you to implement on Excel, all right? Just let you know, all right? Now, for the time series decomposition, I won't spend too much time to talk about time series decomposition because this part is also very important, but it's a little bit, it's can be viewed as the extended material related to within this chapter, all right? So basically, conceptually, this topic, the time series decomposition, basically is trying to separate out the different factors within the time series analysis. Okay, and the to be honest, the math part is a little bit sophisticated and probably need a few different um, uh, calculations behind. All right. So instead of actually asking you guys to calculate the time series decomposition, okay, I decided not to actually. We will not cover some calculation or problem solving questions related to time series decomposition, okay, but I still highly recommend every one of you, all right, to look over this section, all right, related to time series decomposition to at least give you some sense about what it means and what it relates to, and how you can kind of quantitatively calculate this whole procedure. Okay, if you actually really want to understand, some specific detail or the techniques about it, feel free to let me know. Okay, we can discuss. All right, and but for the conceptual part of the time series decomposition section, okay, I still require you guys to understand basically what time series decomposition is doing conceptually. All right, so basically from most large big point of view, basically time series decomposition is trying to separate out different sections or separate different factors, right? Separate different factors or elements like the trend, seasonal, clinical, autocorrelation, and random, something like that. All right. At least in most standard question, you need to basically separate out the impact from trend and seasonal. Okay, that's it. So that's why I do require every one of you to look over the textbook, actually at least to conceptually understand what it's doing here. All right. So basically, I think the textbook already provides a very clear description about the time series decomposition. Okay. Um, Actually, both from the conceptual way and also the quantitative way. So quantitative method, if you are a little bit hard for you to do the calculation, that's fine. But for the conceptual part of view, look through all those things, try to understand exactly what it means, right? That's actually very important. Okay, and also the conceptual part may be covered within the exam. All right, but I won't spend too much time talking about the quantitative. You see all these few slides related to the decomposition quantitative methods. Okay, but as I said, if you're interested, let me know. We can discuss through it. Okay, that's actually very, very interesting. Yeah. Now let's move to the forecast errors. Okay. Actually, at the beginning of this class, I already say that for every forecast method, you cannot actually fully or entirely capture all of the information in the history. All right, or we can say there's no single forecast method that can give you perfect forecast. What it means by perfect? Basically, the forecast is exactly the same as the actual one. Okay, it's almost impossible in the real cases. All right, so that's why actually we always facing the difference between the forecast and actual. All right, but as long as this error itself, okay, is acceptable, you're good enough. All right, but how to measure the forecast error? That's also a question, right? So here we basically give you three different measurements to measure the forecast. All right, sorry, to measure the forecast error. All right, which are called mean absolute deviation, mean absolute percent error, and the tracking signal. Okay, actually, mean absolute deviation is already covered within the BSTAT course, but here I will repeat it again to give you some great sense about what it means. And since actually mean absolute deviation is also related to the other two techniques, which are mean absolute percent error and the tracking signal. Okay, now let's look at this. First of all, first let's look at the forecast error measurements. All right, starting from the mean absolute deviation. So ideally, if there is no difference between your forecast and actual amounts, the mean absolute deviation should be zero. Okay, mean absolute deviation should be zero. And you can even imagine actually when mean absolute deviation is higher, okay, it means that your error level is higher. That's it. Because since this measuring the forecast error, right? And that's why actually when this value is becoming larger, it means that your forecast error is larger. Okay. And if it's already above an accepted level, you should be cautious. All right, because you want to be your forecast as accurate as possible. So you don't want actually this number to be too high. All right. Now, what is the mean absolute deviation? How to calculate this? Very simple. Okay. Sorry. So the mean absolute deviation, the equation is exactly shown here. All right. Still, remember what I just said, right? This symbol is called summation, right? Summation basically summate what? Summation the actual amount within period t minus the forecast amount in period t, and then takes the absolute value and then sum up. All right. Basically, for every element, you calculate the absolute value of the difference between AT and FT, and then you sum it up to get to your numerator, and then divide by n. Divide by n to get the mean absolute deviation. That's it. All right. So that's how we get mean absolute deviation, and I will use a quick example to illustrate. All right. Don't worry about it. So the next one is called mean absolute percentage error. Mean absolute deviation itself is basically a value amount. All right. But sometimes we may, instead of using the value amount, we may use the percentage amount. Okay, percentage amount. So when we try to use the percentage amount, here we want to scale it based on the magnitude of the actual demand. Okay, that's why you see when we count the mean absolute percentage error, we simply use mean absolute deviation, basically from this equation, but we divide it by the average actual demand that we used. The average actual demand that we used. Okay, very simple. This is the second one. The third one is called tracking signal. Tracking signal basically indicates whether your forecast errors are accumulating over time. Okay, basically, if you are trying to measuring or trying to monitoring your forecast error in a period of time, right? You basically need to look at the pattern, how it goes, right? That's why we need a tracking signal. That's why we need a tracking signal, all right? But also the tracking signal itself also is related to the mean absolute deviation, the mean absolute deviation. All right. So we will detailly talk about the how to get the tracking signal. Okay. just in a second. Very simple to calculate actually. All right. Now let's use. Let me see. Okay. Now let me use this quick example to illustrate the forecast error. Okay. First of all, let's suppose the first three columns: month, forecast, actual. Okay, forecast market demand, actual market demand in different months. These three columns are given. All right, let's say in the question, I give you the three columns, and then I want you to calculate the mean absolute deviation, the mean absolute for percentage error, and also the tracking signal. How to calculate it? Very simple. First of all, we need to calculate which one, mean absolute deviation, right? So how to calculate mean absolute deviation? This will be the equation. Remember, before we sum up, we need to calculate every element. The every element would be the absolute value of the actual amount in period T minus forecast in period T, right? How to get that amount? The actual amount is 950. The forecast amount is 1000 in month 1, right? This will be the first element would be what? If you use 950 minus 1000, it would be negative 50. But remember, here is the absolute value. Okay, remember that there's an absolute value showing here. So that's why instead of using negative 50, you need to use the absolute of the deviation, which is 50. Okay, which is 50. That's why the first element would be 50. The second one, still use actual minus forecast would be 70. The absolute value of 70 is still 70. That's why here, this is 70. If you follow the same fashion, you will get the list of these numbers. All right. You see, every row will give you one corresponding element, but you need to sum it up because in the numerator, you need to sum it up. That's why here, you basically need to sum up all these elements, okay? If you calculate yourself, you will see that actually this result will be 400, all right? And then you divide it by what? N. N basically just how many pairs of it, right? Since you have 6 mouses, you have 6 pairs, that's why you divide by 6. That's why this is 66.7. That's it, very simple, all right? So basically, the mean absolute deviation is just 66.7. That's it. Now, the mean absolute percentage error. The mean absolute percentage error, you see, is actually coming from the mean absolute deviation, but it's a little bit different, right? The mean absolute deviation, the mean absolute deviation itself, we already got this, right, for the numerator. But what is the denominator? Since we're trying to scale, right, scale to the magnitude of the actual demand, the actual market demand, right? So what is the average market demand? What is the average actual market demand? How to calculate this? Very simple. So basically, you know that from month 1 to month 6, this is the list of the actual market demand, right? This is a list. How to calculate the average? You add all them up and then divide by how many? 6. That's your actual market demand. What is the actual market demand? If you calculate yourself, you'll get this result, which is 1036.7. That's it. Okay, 1036.7. And then after you get this amount, you use 60.7, which you get here for mean absolute deviation, divided by the amount that you just calculate, you will get this amount, which means 6.43 percentage. What it means? It means that 6.43% of your forecast, okay, is wrong. But equivalently, it indicates that, okay, actually around 94% of your forecast is great, right? That's already good enough because we cannot actually anticipate 100% forecast, okay? Now, the last one is called tracking signal. Here, the table actually show you basically a sequential way or an iteration way of doing tracking signal, okay? I would like to provide you a better method that you can use right here, all right? So in order to calculate the tracking signal, you see here the numerator is 220, all right? It's easier, okay, by directly, okay, just adding up all of the actual amount. You'll get an amount, right? Minus this summation of all of the forecast. Let me repeat again. If you add up all of these values showing this actual amount column, you will get an amount, right? If you add up all of the numbers showing this forecast column, you will get another number. You use this number, use this summation, minus the summation here, you will get this value directly. Okay? So in order to get the numerator for tracking signal, just using the summation of actual amount minus the summation of forecast, you get this amount. And then divided by, again, 6.7. Still, mean absolute deviation, you get 3.3. Okay? That's how you get the tracking signal directly. Okay? But you can also use this way to go through, iteratively, finally still get 3.3 shown here. You see? Okay, either way is fine. You can actually do both. All right. Yeah, this is okay. So that's all for forecast error. All right. Now let's move to the causal relationship forecast. Actually, we already talked about some related to causal relationship, right? So when we talk about the linear regression stuff, so the causal relationship forecasting basically is using the independent variable and also the dependent variable to kind of predict the future market demand, right? So this is exactly what the linear regression stuff is doing, right? That's why we already did that. We just talked about the simple linear regression. Here, further, we can also have multi-regression. Actually, the key sense of the simple regression and multiple regression is exactly the same, all right? So the only difference is that if you have one independent variable, it's called simple regression. That's it. If you have more than one independent variable, okay, it's corresponding to multiple regression. Okay, very simple. So if you are basically talking about the relation between y and x1, is simple regression. If we're talking about the relationship among y and x1, x2, or x3, or x4, okay, as long as the number of x is greater than 1, it's corresponding to multiple regression. And the implementation itself, okay, especially within Excel, is exactly the same. All right, so there's not there's not very too much difference actually between simple regression and multiple regression. And of course, for the simple regression, you can manually calculate as what we just did for A and B, right? But for multiple regression, probably you have to use the software to calculate. Okay, so but here, of course, we want to actually let you guys to calculate manually for the multiple regression. Okay, but just give you a sense about why, what is the difference between simple regression and multiple regression. Okay, here I have a classic example. Right? Since I just already talked about the another linear regression, by manually calculating, right? Here you can use this simple example to kind of verify the numbers that I get. All right. So you can manually, since this is related to a simple regression, right? So you can manually calculate both A and B values. Okay, the number is already showing here, but you can manually calculate. You can also use the Excel to double check it. All right, you can use Excel to double check it. But once you guess the value for A and B, basically you're ready for forecasting, right? You're ready for forecasting. So basically, you are already building up a relationship between the forecast of the demand and the time, which is the period, right? So you see that here, this can be the independent variable, but you know that actually mathematically you cannot use generate this verb as a this word as an independent variable, right? So here, that's why here we view it as 1, 2, 3, 4, 5, 6. So July would be automatically be 7, right? So that's why here, after you get 14.8 for A and 0.77 for B, you times what? 7 in order to get the forecast for July, which is 20.19. That's it. Very simple. All right. Yeah. Try to double check and verify all the results I show here. If you get a different result, let me know. I can help you to figure it out. All right. Now, the qualitative forecasting techniques. Yeah. So the qualitative forecasting techniques normally will include also include some different aspects. All right. But no matter which different methods that we're talking about within our qualitative forecast techniques, there is a key point that's inside the qualitative forecasting techniques. Okay, because qualitative forecasting technique always will include the management judgment. Okay, so in most cases, although the management judgment is a little bit subjective because it actually depends on people's real judgment on certain decision, right? But actually, in many cases, actually, the management judgment itself is very important because the mass equation or math formulation that we just use within the quantitative methods cannot capture everything, okay, that happens in real life. That's why we do need the management judgment. Okay, so sometimes we may use the quantitative management as basement, and then we still need to call it, this management judgment to further, fruit your whole forecasting method. Okay, and of course there are some examples within the qualitative forecasting techniques, like the market research. Right, you need to do the market and see whether customer is satisfied by the product. What are the improvement things that you need to um, further investigate on? Those are things, right? The panel consensus, the historical analogy, Delphi method. Okay, so actually the textbook, as I said, the text will already give you a very uh, clear and also very, I think, very decent description about the, about every examples. Okay, so please view all those, paragraphs. Okay, at least have a sense about, okay, what is the key point for every example and what is the difference among different examples. Okay, that's what you need to do by just looking at the textbook. All right. The last one would be the collaborative planning, the forecasting and replenishment. All right. So basically, the collaborative planning itself basically is you trying to use the different techniques together simultaneously in order to further improve your forecasting power. All right. We may use the quantitative method, use the qualitative method, like I just mentioned, right, to further improve your forecasting method. We may also simultaneously use the software, right? Since right now the computer science is very powerful. You may not actually manually calculate something. You can use those stuff, use the code to optimize, a lot of things. That will actually improve your efficiency, vastly, right? That's actually very important. That's why here you see that the collaborative planning, forecasting, replenishment, CPFR, this whole process basically, you see, this is a web-based process, and we coordinate the efforts of the supply chain from many different aspects. All right, that's the key point of here. So if you're interested about the collaborative planning, forecasting, and replenishment, all right, which is called CPFR, also look at the textbook. It already give you a quick sense about what it means and what kind of different techniques we will incorporate. Okay, as long as you read through it, I think you already get a great sense about it. Okay, so you see that actually within this chapter we mentioned many different techniques, right, to forecast the market demand. All right, so all of those quantitative methods, qualitative methods, or some collaborative methods are important. The goal is the same: is trying to improve your forecasting power, your forecasting, ability. Okay, and that's also would be one very important topic within operations management forecast. So that's all for today's chapter. Thanks for watching. See you guys.